Problem 23 on problem set 2 is also kind of strange. It's a chain rule problem, but usually in chain rule, all that I told you about what you do in chain rule is if there's an equation inside of another equation. And problem 23 is different because there's actually an equation inside an equation inside an equation. So it's an extra step, but it kind of shows. You could have like 100 equations inside of each other, and chain rule will still apply to them. But so let's take a look at problem 23. So it's f of t equals 2e to the minus 2e to the 2t power. So this is an equation inside an equation. It's this whole thing here. This whole thing here is inside the equation e to the x, right? So that's inside an equation. But notice there's an equation. There's also an e to the x inside of that. That's the equation inside the equation. But notice right here, I don't have e to the x. I have another equation instead of x. So that's a doubly nested chain rule or composition function. But how you do this is just the same way you do any chain rule problem. Is you just do the derivative of the outside equation and leave the inside equation the same, and then you multiply it by the derivative of the inside equation. So here's what I mean. So the derivative of e to the x is just going to be e to the x. So when I apply chain rule, here's what I do. Let me make this smaller and move it off to the side. So really what I want to think about is this thing as just e to the x. There's a constant out in front, but that's okay. I'm just going to leave the constant by itself. It's just going to sit out front and do nothing and wait for me. So f prime of t, it's going to have my constant out front. It's just going to wait for me. And then I want to take the derivative of this, and I'm just thinking of this whole thing as the outside equation. This whole thing is e to the t, and the derivative of e to the t is in fact e to the t. So the derivative of e to the minus 2e to the 2t starts out with the exact same equation, e to the minus 2e to the 2t. So what I've just done is I've just taken the derivative of the outside equation, and as we know, the derivative of the derivative of e to the x is just e to the x. So the derivative of all this is all this. But this part is not just x, it's another equation. So I have to multiply now by the derivative of this stuff. So I'm just looking at this stuff now. And I do the same thing. The derivative of this stuff, I'm just going to leave the 2, that's just a constant out in front. So it's going to be times minus 2, and then I want to know the derivative of e to the 2t. So, but that's not just e to the t, it's e to the 2t. So I have to apply the chain rule. But the outside equation is e to the t, and the derivative of e to the t is just e to the t. So the derivative of e to the 2t is just e to the 2t. So this is going to be 2 times the derivative of e to the 2t, right? But it wasn't just t. Then once again, I have to multiply by the derivative of the equation inside the equation, and the derivative of 2t is just 2. And I guess I need to make myself some more space, but fortunately I can't make myself some more space. Fortunately, I can move this a little bit. Oh, maybe I can't move this a little bit. There we go. I can scrunch it all together. The derivative of 2t is the equation inside of the equation, e to the t. The derivative of 2t is just 2, so I have to multiply by 2. Okay? So, and then I'm done. Now I can simplify usually what I'll simplify, I can bring this 2 out, can bring this 2 out, and I can multiply those two times 2. And so what finally it comes out to be is 2 times 2 times 2, and there's a minus sign, minus 8 e to the minus 2 e to the 2t times e to the 2t. Alright? And that's how you would do a problem with an equation inside an equation inside an equation. You just keep on iterating on chain rule.